Välkommen tillbaka allihopa. Hoppas ni hade en trevlig fika.
Vi fortsätter eftermiddag med Science-Slam. Science-Slam är en tävling mellan olika föreläsare. Varje föreläsare har 3 minuter på sig att presentera sitt ämne på engelska. Ni avgör vem som presenterar på bästa sätt, mest underhållande och lätt att förstå. Hur röstningen går till förklarar vi vid slutet, men kom ihåg alla föreläsare.
Så dagens första föreläsare heter Lorenzo och han är doktorand på institutionen för geovetenskap. Hans tävlingstitel är Let's Explore the Unknown Extreme Climates. Varsågod.
Okay, I want you to imagine that you have to play a really important game with your team. Could be a football team, volleyball match, or basketball match. And it's really important for you to not lose this game, otherwise you will not win the championship. So when you prepare this game, you will probably think and look at the general quality and skills of the other team. But if you really want to be sure that you will not lose, you have to also look at the most dangerous players. Those kind of players that can score more goals, and then can be more dangerous for your defense. And you will probably think, oh, why is or she so dangerous? Can I kind of understand and prevent the movement that are so dangerous for myself, for my team? And I'm not dealing with sports challenges, but I'm doing the same for the climate change challenge. And I look at those really dangerous extreme climate events that they can cause loss, that are really dangerous for us. For example, they cause loss of life, then dangerous to our properties, can kind of block us inside our house because it's too dangerous to be outside. And I'm talking about this type of events like can be heat waves, extreme rainfall, storms, and so on. And what I try to understand is why those events occur. Will they change in the future? And why? We will be able to kind of be ready to face them, or we will be defeated. That's my research. Thanks.
Tack så mycket. Nästa föreläsare heter Nick Weckenhuisen. Han är doktorand på institution för kemi och molekylär biologi. Hans föreläsning heter Get to know them at individual single cell study of population. Välkommen.
Hey everybody. So what I do in my research, I develop techniques to study single cells by a microscope. So you wonder, why do I actually study cells on a single cell level? Well, if you look around you, to the left, to the right, you will see that everybody's different. Everybody has different hair color, everybody has different gender, and so on and so on. And this makes us all kind of behave different. And let's think of an example, for example, running. So you can imagine that somebody who has the age of 20 would run in general faster than somebody of 60. Or babies, for example, they don't run at all. But if you would look at an average of the whole population, everybody would run at the same pace. At the same pace. So you would actually not know that babies don't run. And for humans, this is easy to test because you just time how fast they run from one side to another. But the human body consists of millions and millions of cells. And for example, bacteria culture also has millions of cells. And these cells are also all individuals. So let's do a little experiment. Here I have candies, and we can imagine that these candies are all single cells. And so most traditional experiments, what they basically do, they basically you grow your whole population of cells, you basically put them in a mixer, and then you mix it. So, like this. And then if you analyze this, you would actually say, but all my cells have, they all have yellow, brown, blue colors. While actually, if you look at every individual candy, we actually see that all of them, some are yellow, some are green, some are brown. So by looking on a global level, we actually miss how cells are individual. And for example, a cancer cell in a tumor, all cells behave different. And so by looking how these cells behave different, we can actually learn more about the tumor, how it works on its whole.
Tack så mycket. Vår nästa tävlande heter Lashi och han är postdoc för Matematiska instituten här på GU. Och hans tävlingstitel är Maths and Sharp Edges.
So, geometry is everywhere. It's you, it's all around you, and you definitely couldn't have missed it on the way here. So mathematically speaking, geometry is the study of the structure, the size and the shape of space. So I've arranged to you an assortment of my favorite geometric objects. And if you look around you, you'll also see that we're inhabiting a part of the universe. And that's also a geometric object. But of course, I didn't prepare for that earlier for you today because that's a bit difficult. And you see the mask, the horse mask here, it has a mouth and it has nose holes. And that actually makes it structurally different to the other objects that I've placed here on the table. And if we imagine this knife to be hollow, or if we imagine these balloons to be filled in, then the other remaining objects are structurally the same. But you can see that they're different in size and in shape. So since we live in an age where we can always divide things up into two different kinds, let me say there are two different kinds of geometries. So there's the smooth geometries, and then there's the rough. And what do I mean by that? Well, you see, there's a tip here, and it's sharp, and that's what makes it rough. And intuitively, we can see that tip has a lot of curvature. And rough geometries are abundant in reality, and I like it rough. Just a bit of a punchline. To study rough geometries and associated rough problems is difficult, and the way we study them is to access methods from harmonic analysis. So simply put it, harmonic analysis is the study of complex signals from simple ones. Your mobile phones are sending complex signals out all the time. They're carrying complex information. And I can see some of you are using Facebook. So, but in an appropriate sense, these are all simple signals. So if I apply this philosophy to rough geometries, we can figure out exactly how to extract simple parts from the more complex things. But who cares? Do you? Do I? Well, you see, to the mathematician, we want to study problems that are beautiful. And applications are a luxury that many mathematicians cannot afford. But let me try and explain to you by quoting the great physicist Richard Feynman. He said this about physics, but it's true about maths. Maths is like sex. Sure, there are practical consequences, but that's not the reason we do it. So, but to be serious, let me say that there's a worth in studying abstract problems because they can provide perspectives that we cannot anticipate in advance. And of course, it's a bonus if they do become of practical value. Thank you.
Thank you, Lorenzo. Sista tävlingdeltagare heter Fabian Roye. Han är doktorand på marina vetenskap och hans tävlingstitel heter Why we lose species and why we should care. Välkommen upp.
Hey, so I'm an ecologist. And if you ask Google autocomplete what ecologists are, then we are, 1, concerned about global warming, and I hope you all are. 2, important. And 3, concerned about invasive species, leaving that one for another time. Fourth, unsettled. So if I'm professionally unsettled, what am I professionally unsettled about? Well, it's about the sixth mass extinction. Sounds like something you should be legitimately unsettled about, does it? I think so, because it turns out that volcanoes and asteroids are not the only ones that are good at exterminating species. We are pretty good at this too. So how do we do it? Well, global warming, invasive species, and most of all, habitat destruction, or it is called sometimes, and it's euphemism, land use change. And with all of that together, we are actually exterminating, losing species at a rate that was observed the last time during the Cretaceous Tertiary extinction event, better known as the time when a giant 10-kilometer big asteroid wiped all non-avian dinosaurs from the face of the Earth. Okay, so really? Well, we don't quite know. But if we're not quite there yet, it's not because of lack of trying. Have you ever wondered why everybody's always pointing to Brazil that they should protect their rainforest, and nobody ever asked Germany? Well, besides the fact that Germany doesn't have any rainforest, it's Germany is 50% agriculture, 25% planted trees, 25% urbanized land area. They don't have any natural habitat left to save. While the Brazilians were drinking caipirinha and celebrating Carnival, we Germans rolled up our sleeves and got the job done. Okay. So with that being said, why should we care? So if you're still asking, I think that's kind of cynical, but then I don't think I need to come here with the argument, with the moral argument that maybe we shouldn't wipe off species from the face of the earth. But well, consider this. You're sitting in an airplane, cruising over the Atlantic, minding your own business, and you look out at the wing. And then you see that one of these little rivets, nits, I think they're called in Swedish, they hold the airplane together. One of them is missing. Well, I mean, there are plenty of them in the airplane wing, so why would you care? Well, at a closer look, you see it's not only one missing, it's quite a few that are missing actually. And at a yet closer look, you see that most of the rest of the rivets don't sit quite tight. And then you remember that the pilot just asked you to buckle up because you're heading into a thunderstorm. Well, now you're feeling pretty uncomfortable. And in this analogy, the Earth is the plane. The species are the rivets. And the global warming is the thunderstorm, but we're not sitting in the plane. We're standing on the wings and ripping out the rivets. And that, ladies and gentlemen, is why this ecologist is concerned.
Tack så mycket Fabian. Det är nu dags för er att rösta, och det gör ni genom att ni ska applådera för den ni tyckte mest om. Så vi kommer gå igenom dem en efter en och klappa för den ni tyckte var allra bäst. Så vi börjar direkt med att klappa för Lorenzo.
Tack. Vi går vidare till nummer 2. Nick Schwekenhuisen. Nummer 3. Lassi Bandara. Sista nummer Fabienne Royer. Tack så mycket för era röstningar. Ska vi bjuda upp alla deltagarna på scenen?
Nu när vi har hört alla era applåder så har vi en vinnare. Det var väldigt jämnt, men den som vann är Larsi. Grattis! Ska vi gå till...
Yeah, we think all of you have those so great, and thank you so much for being here with us. And we have a flower to all of you.
Varsågod.
Ge dem en stor applåd igen.